A lot of time interpreting graphs of polynomials. This unit, we are going to focus on sketching them. So something that we have already done, and this paper that you're looking at is a variation of the purple foldable, is we were able to look at an equation in factored form and name the roots or x-intercepts. So remember, factors are often in parentheses and roots are what x is equal to. So in order to find the roots when given these factors, we would set each factor equal to 0 and solve for x. So I'd have x equals 0, x minus 3 equals 0, 2x plus 5 equals 0, and 3x minus 1 equals 0. Well, here we've already solved for x. To find the solution for x minus 3, we need to do the opposite of x minus 3. We're going to add 3 to both sides, and we get x equals 0 plus 3 is 3. These two are actually two-step equations. So first I'm going to undo the addition with subtraction, and I'm left with 2x equals negative 5. Divide both sides by 2, and I get x equals, and I can put this in my calculator. We're okay to get a decimal here. Negative 5 divided by 2 is negative 2.5. We're going to do the same thing with this last one, but we'll be adding 1 to both sides. So 3x equals 1. Divide both sides by 3, and x equals 0.3. So we have 1, 2, 3, 4 roots here. We're going to do that with the second example. Notice here when we had x minus 3, x equals positive 3 was the actual root. So something to be aware of is when there is no number in front of an x, you can know that the actual root will just be whatever this number is here, but with the opposite sign. So for here, where we have x minus 1 equals 0, we don't even have to work it out. We know x is going to be positive 1. This is squared because it's a double root. It means it's a double root, so I'm actually going to write x equals 1 twice. Here I have x plus 5. Well, I know that x is just going to be negative 5. Now the 4x minus 3, that one I'm going to work out because there are two steps and it might be a little much to do in my head. So I'm going to add 3 to both sides. And I have 4x equals 3. Divide both sides by 4. And x equals 0.75. So these are just the steps for finding the roots when we have the factors. These give us the x-intercepts. So I'm going to actually write that up here. X-intercepts. All right. Now right here we can find the y-intercept. So the x-intercepts are where your graph touches the x-axis. The y-intercept is where your graph touches the y-axis. And that's actually our definition, where graph touches y-axis. And the way you can find that is by subbing in 0 everywhere you have an x. So we're going to sub in 0 for x. So that's our first step. And then plug it into the calculator. So I'm actually going to write this out in the example right here. I'm going to rewrite this equation, and remember that f of x and y, they're the same thing. So I'm going to rewrite this equation, but everywhere I see an x, I'm going to sub in 0. So it is the exact same equation, but I subbed in 0, and I'm going to type it into my calculator exactly the way I wrote it on my paper. And when I hit equals, I get y equals 6. So now you know how to find the x-intercept and the y-intercept. We're just going to skip this example, but you have all the points that you would need to put on your graph if you were to get ready to sketch your x-intercepts and your y-intercepts.